What are radical expressions? Radical expressions are mathematical expressions that involve square roots along with other roots. They can be tricky, but once you get the hang of them, they're easy. It is important to understand radical expressions because they appear in various areas of mathematics and real-life applications. They help us solve equations, simplify expressions, and work with geometric shapes. Having a good grasp on radical expressions can open up a whole new world. You know that box that looks like it has a check mark? That's called a radical. A radical is a symbol used to indicate a root. Next, we have the name of the variables that sit under the house, the radicand. The radicand is the number or expression inside the radical symbol. Finally, we have the tiny little number on the left corner, the index. The index is the number that tells you which root to use. Now, using various difficulty levels, I will show you how to simplify a radical expression. Starting off simple, we're going to find the square root of x to the 10th power. First, you have to simplify the radical by breaking down the radicand up into a product of known factors, assuming positive real numbers. Since we know 5 and 2 give us 10, we're going to simplify it down into x to the 5th power, parentheses, to the 2nd. Assuming the root is 2, the square and the root cancel out, and the x to the 5th comes out, and your final answer would be x to the 5th power. Moving up difficulties, let's try to simplify the square root of 48x squared y to the 5th power. Again, we must simplify the radical by breaking the radicand up into a product of known factors, assuming positive real numbers. But since number 48 is not a perfect square, we cannot simplify it so easily. Instead, we must find two multiples of 48. I decided to use the square root of 16 times 3. Leaving that aside, now we have to break down our y to the 5th power. Our new expression is the square root of 16 times 3, x squared, y squared, y squared, y. Assuming our index is 2, now we must bring out the 16, the x squared, the y squared, and the other y squared. After simplifying them, we are left with 4x y squared square root 3y, and that's your final answer. Moving up the bar, we are now going to try a radical expression where the index is cubed instead of squared. Now that our index is 3, we are going to be finding the cubed root of 27x to the 5th y. Looking at our new radicand, we must find the perfect cube number of 27. Since 27 is a perfect cube number, it comes out of the radical. It's 3. Just like the last expression, we have to break down our x to the 5th power, so it is easier to simplify. Our new expression is 3x to the 3rd times 3x to the 2nd y. Since our index and our exponent are the same number, the x comes out. And our final answer is 3x cubed root of x squared y.
For addition, your 7, 1 plus 17, 1 will equal 24, 11. Now what we did is we combined like terms and which these like terms were the 7 and 17, And since they have square root, we leave them alone. For subtraction, 2117 minus 8, it would equal 1317. First, we subtract 8 from 21, which would be 13. Since the roots are the same, we once again leave them alone. For multiplication, we have 210 times the 3. So what we do is we find the prime number of each radicand, which would be 2 times 3 times 5 times 7 times this. And so then we apply multiplication to the square roots. So then you would have 2 times 2 times 3 times 5 times 7 times 3. So then you would group perfect square factors, which would leave us with 3 times 25 times 7. Then you're going to simplify. So 2 times 5 times 1. So after you've simplified, you're going to multiply, which is going to give you this. Then when you divide, so we have what we have is 18 over 2. So what you're going to do is you're going to combine fractions inside one square root. And so then you're going to have 18 over 2. And then you're going to divide as usual, which would give you
Radicals
9,
have many functions in the real
square root
world.
of
These
9
functions
is
vary from
3.
engineering to physics. In engineering, it is used to describe certain design parameters, and in physics, it is used to show exact type of motions. In medicine, radicals are employed in radiation therapy to destroy cancer cells. Radicals have a very important role in our lives.